Hello, this is video number 17 and it's about correlations. We studied correlations in year 12. In year 13 we're going to take a slightly deeper look at them. Let's start out by remembering and revising what we learned in year 12. A correlation is a measure of the strength of association between two variables. It measures the strength of a relationship between two variables, and we can see correlations by plotting them on a scatter graph. In video number 15, you might remember, we measured the reliability of my marking and Mr. Lemon's marking, and we created a scatter graph. Both myself and Mr. Lemon marked a sample of 16 mark essays, giving each one independently a mark out of 16, and we plotted my marks against Mr. Lemon's marks on this scattergram. And you can see that there is a fairly good agreement between us on the marks out of 16 for each essay, although not a perfect agreement. And so this is a reasonably strong positive correlation, although not a perfect correlation. There are positive, negative, and zero correlations, as you can see from these three scatter graphs here. And the positive and negative correlation is basically about what's the direction of the line of best fit. Does it go up or down? And if there's zero correlation, then there's no line of best fit at all. A correlation does not establish a causal relationship. Just because variable y increases when variable x increases doesn't mean that the increase in variable x causes the increase in variable y. It could be that there's a hidden or an intervening variable there. So for example, I bet that if I measured the homework compliance of a year 13 group and plotted this against their final A-level grade, I bet I would find a strong positive correlation. In other words, the ones who did the most homework ended up with the best A-level grades. Now, is that because the homework causes you to have a better A-level grade? Well, maybe. Or maybe there's a hidden variable there, an intervening variable. Maybe, at a more fundamental level, the students who are more enthusiastic about psychology are the ones who do two things. Number one, they do more homework. And number two, they revise harder when it comes to exam time. And so that hidden variable would explain the positive correlation. So just because there's a strong positive or negative correlation doesn't mean that there is a causal relationship between two variables. Okay, correlation coefficients R. R is a parameter which varies between -1 and +1, and it tells us about the strength of a correlation. Now, have a look at these scattergrams here. And these are scattergrams for a variety of different correlation coefficients. Let's start out with the one on the bottom right. This is a scattergram for a correlation of -0.99. In other words, very nearly perfect negative correlation. And you can see that all of the points on that scattergram are either on or nearly on the line of best fit. In other words, this is a nearly perfect negative correlation. If it was perfect, -1, then the points would be in a dead straight line. Now, compare that to the scattergram on the bottom left. This is a scattergram for a correlation coefficient of -0.7. Now, you can see, in actual fact, that the line of best fit is the same. But there's more variability in this correlation coefficient. It's a less perfect correlation. There's greater deviation from the line of best fit. And equally, the one in the top middle, -0.3, there's even more variability. But the point is, the line of best fit is the same in each one of them. So, R is a measure of the deviation from the line of best fit, and it's a measure of the strength of a correlation. Okay, now it's worth remembering that correlations don't work for curvilinear relationships. They only work for linear relationships. So consider for a moment the relationship between performance and stress. So this could be performance on a memory test, or it could be performance on the 100-meter sprint, or performance on anything that you like. There is an optimum level of stress. If we're too relaxed, we don't do very well. And if we're overstressed, we don't do very well either. There is a happy medium. And that means that the graph of performance against stress is curvy. It's curvilinear. And if a graph is curvilinear, then you can forget about using correlation coefficients. They just don't work. Correlation coefficients only works for linear, not curvilinear relationships. Okay, in a minute, we're going to enter my marks and Mr. Lemon's marks into an online calculator for R, but first, it is time for this week's random psychology fact.
This week's random psychology fact is, did you know false memories can be shared by multiple people? This phenomenon was dubbed the Mandela effect by paranormal researcher Fiona Broome.
Okay, the online calculator that I'm using today is socscistatistics.com. It's not a bad one actually because it gives you a value of R and it gives you the scattergram. Okay, so what I'm doing here is I'm entering my marks out of 16 into the X column and Mr. Lemon's marks out of 16 into the Y column. And that means that when I do the scattergram, my marks are going to be on the X-axis and Mr. Lemon's are going to be on the Y-axis. Okay, this website has actually got it slightly wrong actually because R should be a lowercase letter rather than a capital letter. But anyway, let's calculate R. So this shows us that for this data, the correlation coefficient is plus 0.6527. In other words, that's a reasonably strong association between my marks and Mr. Lemon's marks. We're in broad agreement with one another. And reassuringly, the scatter graph on the screen here looks a lot like the hand-plotted one that I did, including this aberrant student here who, on the top left, who Mr. Lemon has given 15 out of 16 to their essay, and I have given 3 out of 16. Okay, so what I'm going to do now is I'm going to invent 2 more teachers. Ms. Mensa and Mr. Donkey, all right? And I'm going to give the essays to those teachers to mark and ask that they record their marks out of 16 as well. And here are the marks that they have generated. In actual fact, I've just made up these marks. But now we can see that each essay has got 4 marks, one from each teacher. So let's have a look at the correlations between some of these pairs of teachers. Okay, so what I'm doing here is entering Mr. Lemon and Ms. Mensa's marks into the online calculator. This time Mr. Lemon's going to be on the X-axis and Ms. Mensa is going to be on the Y-axis. Okay, let's calculate R. And we can see that this time R equals plus 0.9886. In other words, that's a really strong positive correlation. A very strong relationship between the marks of these 2 teachers. And you can see from the scattergram that in actual fact the marks are all nearly on a straight line, indicating that really strong positive relationship between the marks of the 2 teachers. Well, what does this mean? It means that they're in very close alignment, very close agreement with one another. Why is that? Well, the correlation coefficient doesn't tell us why. Just tells us that they are in agreement with one another. Maybe they copied off one another. Maybe they were doing it together. Or maybe they're just both really bright, clever, accurate and precise markers who get the correct mark every time. Maybe my marks are a bit off kilter. Either way, we can see that the correlation between Ms. Mensa's and Mr. Lemon's marks are much stronger than the correlation between my marks and Mr. Lemon's marks. Okay, now let's enter Mr. Lemon's marks against Mr. Donkey's marks. Okay, so what I'm doing here is leaving Mr. Lemon's marks in the X panel, deleting the Mensa marks and entering Mr. Donkey's marks into the Y panel. So let's calculate those. And we can see that this time it's a very different picture. First of all, the correlation coefficient is negative 0.2794. A very weak negative correlation. And we can see that by looking at the scatter graph as well. Maybe there is a slight negative relationship there, but it is very, very weak, close to zero correlation. And that's not a surprise because I generated Mr. Donkey's marks by using a random number generator on my phone. They're literally like random numbers put into the donkey column. Now that's interesting because it shows us that when we put random numbers into the correlation coefficient, sometimes we still get a relationship between the two variables. But that relationship, that 0.2794, is just down to chance. There is no real relationship between these two sets of numbers. And we're going to be returning to that idea in future videos. Okay, so what we've learned in this video is that the correlation coefficient is measured by R. R varies between -1 and +1. It can be shown on a scatter graph, and it's not useful for curvilinear relationships.